Assalamualaikum students. Today I am going to solve the past papers of current and electricity for all the O-level students. These are the MCQs which I am going to solve from the past papers. I am going to solve all the selected questions, so they will be helpful for your CIEs. तो अगर हम इस क्वेश्चन के बारे से कुछ बात करें, जैसा कि हमें ये MCQs का एक पोर्शन सामने दिख रहा है, तो अगर मैं फर्स्ट क्वेश्चन को पढ़ूँ तो फर्स्ट क्वेश्चन तो एक थ्योरेटिकल क्वेश्चन है. इसमें कहा जा रहा है एन इलेक्ट्रिकल क्वांटिटी इज डिफाइंड एज द एनर्जी कन्वर्टेड बाय अ सोर्स इन ड्राइविंग अ यूनिट चार्ज अराउंड द सर्किट. व्हाट इज़ दिस एनर्जी? तो अगर हम इसकी बात करें तो कोई भी ऐसी एनर्जी विच इज़ यूज टू ड्राइव which is defined as the energy converted by a source driving a unit charge around a circuit. तो अगर हम नॉर्मली सर्किट की बात करें तो हमारे सर्किट के अंदर अगर इफ़ देयर इज़ अ रजिस्टर एंड इट इज़ अ बैटरी, तो ऐसी एनर्जी या कोई ऐसी प्रॉपर्टी जो कि एनर्जी कन्वर्ट करने में यूज़फुल साबित हो, उससे हम लोग कहते हैं EMF. वोल्टेज इज़ द वर्क डन बाय द चार्ज इन मूविंग अ चार्ज, whereas anything which converts any energy which converts from other kind of energy can be known as the EMF. The answer will be electromotive force. Next one is the graph shows the current I, voltage V by a graph. Where can Ohm's law be applied to the wire? There are basically three sections in this graph. As you can see, if I'm going to draw this here with respect to this, there are basically three sections in the graph. One is X, Y, and the other one is Z. So according to Ohm's law, V is proportional to I, or more correctly, I is proportional to V. Then V is increasing, so I is increasing, but in this case it is not. So this is known as the ohmic region. Now in the question number 3, the diagram shows a resistor. As you can see in this resistor, the question indicates that the ammeter reading is 0.5 amperes, whereas the voltmeter reading is 3.0 volt. The second identical resistor is now connected in parallel with the first resistor as shown in the diagram number 2. So what we need to do is, this is the second diagram in which the parallel resistor is connected. What are the ammeter and voltmeter readings in the circuit given below? As you can see in this diagram, there are 4 values, which includes the ammeter reading and the voltmeter reading. So I am now going to solve this question in front of you. So as we can see in the circuit, there is a voltmeter connected with 2 resistors whose resistance are identical but are not known, and there is an ammeter. Ammeter gives a current of 0.5 ampere, and the voltmeter has a battery has a voltage of 3 volt, as you can see in this diagram. So now I'm going to solve it. First of all, I need to calculate this R. In this previous circuit, the battery, the ammeter, and the voltmeter is connected with a single resistor. So with the help of this diagram, I'm going to solve this to find the R. So R is V upon I. V was given to us was 3 and the current was 0.5. So by solving it, we can get 6 ohms. Now as this is a parallel combination, I'm going to find the R equivalent. The R equivalent will be, as you can see, in parallel combination, resistors are added like this. So it will be 2 upon R. On reciprocating, R upon 2 gives us 3. It means each resistor has a resistance of 3. So now the question is very similar. The voltmeter is reading is 3. All these are parallel with this. So the voltage across each will be 3. The voltage across this will be 3. But we need to find the current. So V is equals to IR. V is 3. I is need to find. R is also 3. Both are cancelled out. The current is increased to 1 ampere. So the reading of the ammeter will be 1 ampere, whereas the reading of the voltmeter is 3 volts. Now in the question number 5, as you can see, the table shows the part of color coding for the resistor, which resistor has a value of 2700 ohms. So the terminology for solving this is that let's suppose this is a resistor and let's suppose there are basically 3 bands just like this. The trend is that the first band gives a number, the second band gives a number, and the third band gives the power of 10 raised to the power. So it is very clear. As you can see in this diagram, 4 is indicated by yellow, 7 is indicated by violet, and 10 raised to the power 2 zeros, it means it will be 10 raised to the power 2. So it will be indicated by red. So the color coding of the resistor will be yellow, violet and red. So it means the option will be A. Now in the question number 6, I'm going to read this question. The wire has a resistance of 8 ohms. A second wire made of same material has half the length and twice the cross-sectional area. What is the resistance of the second wire? So now I'm going to just a similar question. So length and area are incorporated in this question. So the question will start from this section. R is equals to rho L upon A. Initially it has a resistance of 8 ohms which is mentioned. The final resistance will depend on the final length and also the final area. According to the question, the final length is half of the initial and the final area is twice of the initial area. As there are 2 denominators, then it will jump towards this. So the new number will be 2 2s are 4A. As this value is already mentioned, which is 8, so the new resistance will be 1 upon 4 times of 8. On cancelling out, I am going to incorporate the answer, which is 2 ohms. In the question number 13, you can see the diagram shows the circuit. The ammeter has a negligible resistance and all the values are incorporated in it, and we have to find the unknown resistance of this resistor, which is basically R. So now I am going to solve this question in front of you. So just like this, as we can see that there is a battery. In parallel there is a voltmeter which is giving us a reading of 3 volts, and then along with it an ammeter in series is connected which is giving us a reading of 0.5 ampere. There is a resistor whose resistance need to be finded, and there is a resistance of 1 ohms connected like this. As you can see, it means the battery has 3 volt because in parallel the voltage is considered to be constant. Simply a question of Ohm's law, and Ohm's law is just like that. V is equals to I into R. Voltage is need to be 3, current is need to be 0.5. As we can see that the current will be constant in this series circuit. Voltmeter is a device which measures the voltage without drawing any current, so it will not use it will not use any amount of the current in that. But as you can see, these both resistors are in series, so I'm going to put the equivalent, which will be R plus 1. Just a simple of solution, it will get 3, and by minusing it I will be able to calculate the resistance, which is 5 ohms. So students, now we are discussing the question number 15, which is saying that which circuit shows the correct position of the fuse and the switch in the lighting circuit of a house. This is the fuse and this is the circuit and this is the neutral wire. As you can see, this is the live wire and this is the neutral wire. So the concept in setting all of these situations is that if this is a wire, as you can see, let me zoom out this. This is a supply, live wire, this is the device, and this is neutral, which is taking all the current back to the logic of the fuse is that It prevents high amount of current flowing through the main device in order to prevent it from burning. So the fuse should be connected with the live wire before any device. If it is connected after any device, then its work will be useless for us. So the correct option will be A. In the question number 39, it is a very simple question in which we just need to point out the correct path to indicate this. The student tests the circuit of a press button telephone with a lamp and a battery. These are basically all the numbers which are need to be pressed in order to dial a number before calling. The student has connected a bulb with a battery and he wants to check that which switch is working currently. So we just need to point out and we just need to make the circuit complete in order to rectify the switch which is used to light up the bulb. So if we just trace this diagram, then we just need to complete the circuit by using the path. So we can say that these 1, 4 and 7 are useless for us because they make no connection with the main circuit. So and these 1, 2 and 3 are also. So according to me, if I check number 8, by closing this 8, the current will go through this. The circuit is not completed. Simply with this. But if I close the 5, the current will start moving through this, here, then here, and the circuit is light. The circuit is completed, and the bulb will be on.